Hello friends, in this lecture we will learn about selective repeat ARQ, automatic repeat request. Okay, so this is used for error control and flow control. So what is it all about? So there is a sender and a receiver, and our main aim is of flow control and error control. Flow control means the receiver is never overwhelmed with the sender. He always receives as much as he can process. Okay, and if there is an error, okay, so I'm sending some frame, there is an error, that should also be handled. So these are the aim of selective repeat request. The feature is that it sends ARQ as well as negative ARQ. Okay, ARQ means I have received the frame, particular frame. NAQ means I have not received this particular frame, please send me back. So let's try to see what happens. There is a window, okay, sliding window. So this also comes under the sliding window protocol. There is a sliding window, okay, and it has size 2, which means I can send 2 packets without caring for ARQ. So S is 0 here, okay, which means I can send frame 0, okay. So this window has S, F, S, L, okay. So this is the window size. S represents the last frame that has been sent, okay. So S is 0 means that in this window I have sent frame 0. I am expecting an ARQ, and this one which is after S in the window, those are the packets which I can send but I have not sent yet. There is a receiver window which says that okay, I am expecting these packets, and if you send these packets I will accept them. So sender sends frame 0, that's fine, and sender also sends frame 1 because I can send the size of the window, that many frames I can send even before getting an ARQ. So you get frame ARQ 2, which means now I am expecting frame 2. Okay, so now the sender sends frame 2, but somehow it gets lost. Okay, it gets lost, but I don't know yet. I have started a timer here. So then I send frame 3. Now what happens? This receives frame 3 and it knows that okay, I have in this window I have received this, but I have not received frame 2. So it sends a NAQ. NAQ tells NAQ 2 means I have not received frame 2. So now this one knows it and it sends frame 2 again. So now it has received both the frames. Okay, let's try to see. So selective repeat, we were also doing the same. There was sender and receiver window, but the thing is, so there was in this window there is what? The SF is the starting of the window, SL is the end of the window, and S is the last sent frame. Okay, and here what happens in the receive window in the go back end protocol, it was just size 1, but here the receiver window and sender window, this sender window and receiver window, both of them have size 2 to the power of m minus 1, where m is the number of bits to represent the sequence numbers. Okay, so if m is 3, so in our go back end protocol we could have 2 to the power of 3 minus 1, 7 will be the size of the window, but here the size of the window will be 2 to the power of 3 minus 1, which is 4. Okay, so 4 will be the size of the window, so only half of the sequence numbers, and we will see why it is so. So there is a sender window and there is a receiver window, and this is how it happens. So here if you see m is equal to 2, which means the sender and receiver window size are 2 to the power of 2 minus 1, which is 2. So NAQ represents that I have not received that particular packet. So frame 0. Now let's try to see selective repeat. So I send here, let's try to see why we have the window size as 2 to the power of m minus 1. So let's try to see. So I have m here equal to 2, so window size is 2. So I send a frame, let's say all the acknowledgements are destroyed. So I send frame 0, the acknowledgement did not come, but I can send frame 1 because of the window size. Now what happens? Now because I was not receiving any acknowledgement, there will be a timeout and I will send frame 0 again. And then what will happen? What will happen with this? So this frame 0 will be discarded now because this receiver had received that frame. So it means that if the window size is 2 to the power of m minus 1, there will be no ambiguity in the sequence numbers. So if frame 0 arrives again, then it means I can know that okay, this is for the same frame that I have received. Okay, but let's see here what happens if m is still 2 but the window size has become 3 now. So we have now the sequence numbers can be 0, 1, 2, 3. I send frame 0, I don't get ACK, S becomes 1, I send frame 1 because whatever is the window size I can send those many frames. So frame 1 I can send, S becomes 2, frame 2 I can send, in fact I send, then what happens? All the frames I have received here. And then what happens? But because I was not receiving any acknowledgement, all of them were lost. So a timeout occurs for this one and I send frame 0 again. But what will happen is, because now it is expecting frame 0, it will think that okay, frame 0 was of this particular next one. So it gets confused and it erroneously accepts this one because of the cyclic nature of this sequence numbers. So your frame size should be 2 to the power of m minus 1. So this is about the selective repeat